Okay, let's do chapter 10, part 2. And I want to talk to you about the optimal purchasing rule. Life's a little more complicated than our story about the kid collecting blueberries. So we've got to figure out how to maximize total utility when you've got a budget and you've got multiple things to choose from. First things first, let's talk about budgets. The budget is the constraint that you're up against because any consumer is going to have a limited amount of money that they're going to be able to work with. They are also going to have to face current prices for goods in the market. And they're going to want to know which bundles they can afford. In other words, which combinations of bagels and salmon. So I've got an XY space over here. Salmon will be our X good. Bagels can be our Y good. And in this XY space, any point represents, of course, a certain amount of salmon and a certain amount of bagels. We want to know if we can afford that bundle. Can we afford this bundle? What about this one, and so forth. Mathematically, you can express the budget constraint like this. That'll help you out if you're interested in some of the stuff in chapter 10, appendix. But in real common sense terms here, the easiest way to start seeing which bundles you can afford is to take your budget and you are going to divide your budget by the price of one of your goods. Let's divide it by the price of salmon. And this tells us that if we were to spend all of our budget on salmon and none of it on bagels, we would be able to get 5 salmon and 0 bagels. In essence, what we've basically just done here is we decided that we were going to have y here equals 0, and then we were solving for what amount of x we would be able to buy if we spent all $40. You can do the same thing for bagels now. You asked, what if you spend your whole entire budget on bagels? And if you do that, you're going to be able to see that you could buy 20 bagels. Okay. So, of course, what you're going to get here is your y-intercept. And you'd be able to have 20 bagels or 5 salmon. And connect those two together, and you end up with your budget constraint. This isn't quite to scale. It should be steeper than this, but you get the point. Anything that's on your budget constraint is a combination of bagels and salmon that is exhausting your budget. You're spending all of your money, and you can still afford it. Anything that's out here is not affordable. This may remind some of you of the PPF. And of course, anything that's inside, like this one, is letting some of your money lay idle. So we'll talk about this as idle budget. All right, there's the basics of the budget constraint. Obviously, if I give you more money, then you're going to want to move the budget constraint out. If you have less budget, the budget constraint is going to come in. And if your prices change, you have to resolve for your intercepts. So if we actually make salmon $4, then of course what you'd end up with then is instead of only 10, you'd be able to afford 10 salmon, or I'm sorry, instead of only 5, you'd be able to afford 10 salmon now if you spent all of your cash there. So your budget constraint can wheel like this. Of course, if you're changing both prices, you got to refigure both intercepts. There's the basics of a budget constraint. Okay, so the budget obviously helps you understand your choice set, essentially what you can afford, but it hasn't actually told you which bundle you're going to prefer. Your information about marginal and total utility is going to tell you which units of goods actually bring you the most happiness. But we need to merge those two together in a way, because what we really need to do is we need to figure out, one, where you're going to put your money. And the common sense answer to that is the right one. You're going to put your money wherever it's going to generate you the most happiness. You don't want to throw money away at things that does not generate you happiness. And it's okay if things are really expensive as long as they generate you lots of happiness, right? If they are really expensive and they don't, then you're not going to want them. And of course, just because something's cheap doesn't mean it's great if it doesn't actually make you happy, right? So, got a couple of things going on here. You want to make sure that you're spreading your money around in a sensible way, and you of course can't maximize your current happiness if you have money lying around idle. Okay, so let's formalize that and put it into a couple of rules that you should memorize. Okay, let's formalize those two intuitions from the last slide. First, you want to make sure that you're buying a bundle that's on the budget constraint. You can't afford any of the ones outside, and the ones inside leave idle money, so that's not going to allow you to maximize utility in the current period. Second, we'd like to see that the last unit you bought of salmon was generating a marginal utility per dollar spent equal to the marginal utility per dollar spent on the last unit of bagels that you were buying. And the way you formalize that in an equation is you want the MU of your last unit of salmon divided by the price you paid for salmon equal to the marginal utility that you generated from your last bagel divided by the price you paid for your last bagel. If that's the case, you know you're buying a bundle that cannot be improved upon. And the reason that that's the case is going to become obvious here in just a second. Let's look at an example. Let's say that your last unit of salmon was generating 32 utils and you had to spend $8 on it. And your last bagel was generating 20 utils, but you spent $2 on it. These two are obviously not equal. This is 4 utils per dollar. And this one is 10 utils per dollar. This implies that the last bagel was getting you 10 utils for every dollar you spent on it, whereas your last unit of salmon was only generating you 4 utils per dollar that you were spending on it. This is clearly a bad bundle because you're not generating as many utils as you can with the amount of dollars you have. This clearly implies that you should be buying more bagels. And if you're spending more money on bagels, it implies that you should be spending less money on salmon. Now, if you think about it, as you buy less salmon, that means that you're moving back up our marginal utility table. So these numbers are going to start increasing. And as you buy more bagels, you'd be moving down our marginal utility table from a few slides back, and these numbers would be falling. Okay? Of course, if these numbers over here on the left are on the rise, while these numbers over here on the right are on the fall, eventually you're going to end up somewhere in the middle where they're going to equalize. So let's say that you finally get to a spot where maybe it's 6 utils per dollar for each good. And when you're in that spot, it's telling you that whatever the combination of salmon and bagels is at that very moment, it is generating the same exact utils per dollar for either one of the last units. There's no way to make a marginal improvement and to buy a little more of one or a little more of the other without actually getting more money. And with the money you have, that's as well as you're going to be able to do. Okay, so we've walked through a little example. I hope it's obvious to you now that once you've got all your money in play and there's no sort of adjustment you can make to your bundle, that you've done as well as you can from a total utility perspective. And this might sound a little esoteric and weird, but it's really not trying to do anything other than describe what they believe you're doing naturally anyhow. You might think about a scenario where you're sitting home and you are trying to figure out whether you want to watch DVDs or you're going to go out and you're going to go to a Mariners game. And of course, Mariners games are expensive. DVD nights are cheap. But you're definitely going to want to start thinking about how happy would the next Mariners game you're going to go to make you, divided by the price you're going to pay for it, versus how happy would a night at home watching DVDs divided by a much smaller price make you. And if, of course, it looks like the Mariners are going to give you a higher MU over P, then you're going to buy more Mariners games and you're going to stay at home less, right? But after you've been to a lot of Mariners games, the next one might not be that interesting to you. And your MU over P starts falling. And of course, we make these kind of marginal adjustments all the time. So all they're really saying is people take their money and they put it into the goods that are going to generate them the most happiness. So you try this one below. Hal's got a budget, 16 bucks, milk's $2, honey's $4. I need you to be able to tell me what the correct combination of milk and honey is going to be on his budget, and I need you to be able to explain it using that MUX over PX equals MUY over PY rule. So pause the video now, work this out. It's probably going to take you at least 5 or 10 minutes. After you figure out the correct combination, then you're going to go ahead and get the video started up again, and I'll work you through a solution. Okay, so back to Hal. What I've done is I took the total utilities here that you had on the last slide, and I started to calculate the marginal utility, and then I was dividing that marginal utility by the price. So this first unit generated 32, and the price of milk was $2. 32 divided by 2, MU divided by P, is 16. The next unit generated 28 utils divided by $2 for 14. So on and so forth, right? You get all of these values. Okay? So you got to do that for milk, you got to do that for honey. And I've already got all the numbers plugged in here, so you can go ahead and check them. But once again, marginal utility 44 divided by price $4 gives me an MU over P of 11. The next unit only generates 40 utils divided by $4 gives me an MU over P of 10 for the second unit. So what we need to figure out now is which of these units actually is going to give us a total utility maximization. We're going to use both those rules. So I'm going to identify a couple of pairs here. You have got this unit right here and this unit that if you consumed them, the fourth unit of milk would generate 10 and the second unit of honey would generate 2. You've also got other combinations like this one that would work, and this one that would work. So you got several ways to follow that second rule of your bang over your buck being equalized. The one thing you haven't tested yet is what you have budget for. If you were to go through and start to calculate what the budget can handle, you'd find out in a hurry that this one here, 6 and 6, is way out of your budget. It would cost you $12 for the milk, and it would cost you $24 for the honey. You, of course, only have a $16 budget. So even though you might like this 6 and 6, you can't afford it. Okay, when you test all of these, you're going to find out the only one that you can afford and that will actually land you on your budget constraint is when you are going to take $2 for milk multiplied by 4 units of milk plus $4 for each jar of honey multiplied by 2 jars of honey. And of course, 16 equals 16. You know you're on the budget constraint, and you've got an MU over P that is equalized for both of these goods. That's going to be your solution. Hopefully that helps. It's important to understand this logic. You'll find it oftentimes when you get into finance and you start thinking about people trying to maximize what they get out of their resources. Right? You're going to buy stocks and financial instruments, and you're always going to be asking what kind of return you're getting on these investments for the money that you're putting into them. Right? Investments that generate you more money per dollar, those are the ones you're going to want to put your money into. Okay? So this is a little simpler because it's from the consumer's perspective, and we don't need to think about it over time. Okay? But there's your answer. Hopefully that helps you out.